Right, I think we're live. Is that true? We're live? Okay, good.
Not yet. One sec. It's redirecting. It's taking its sweet time. Okay, you're live.
All right, good stuff. Hello, hello, everybody. Let's see, show my screen. All right, good. I appreciate that you're all here. Thanks everybody for joining. Sorry that we're a few minutes late. We just ran off. I just ran from one meeting to another, and I'm the reason we're late. So appreciate that. Hi. So today we've got some time together, and I was hoping we could talk about Spring Cloud Gateway. We just released Spring Cloud Gateway for Kubernetes. Just in the last few days, we did a whole blog. I did a hour and 40-minute long thing. You know, it's not just a presentation. It's like we got interviews in there. There's, it's like a tutorial with people and stuff. So it's good. So it's good. All that to say, I'm really excited about Spring Cloud Gateway, and I was hoping we could just talk about that. But I need to find out where the comments section is, because I'm not going to have a lot of feedback from people if I can't see where that is. So twitch.tv, Tanzu. Okay, who's streaming now? Okay, good. So that's me. Where's the chat then? I assume. Hi, there we go. Okay, good. Yo. Good. Well, nope, I can't respond back there right now, but I will be able. I can see it, so that's good. So I wanted to talk about Gateway, and Spring Cloud Gateway in particular is a API gateway that's meant to sit in front of your code. It's not a network gateway. This is a thing I didn't realize was a problem until just recently. There is a level of distinction between what a gateway is, like a network. When network people talk about gateways, they're talking about ingress, and they're talking about which bytes go to which destination or endpoint. When I talk about an API gateway, I'm talking about something that helps you with that in the same way acts as an intermediary between your downstream services and your clients, but that cares about higher level concerns. So it's not just like it isn't just like Contour or something like that, right? It's an API gateway will be able to handle things that require awareness of what you're doing, right? Or rather what your payloads are trying to do. And so they tend to be higher order operations, things like rate limiting, things like compression. Well, compression, that's arguably it could be a lower level, but rate limiting and security and these kinds of things. These are things that are a natural fit for an API gateway. Now, when we talk about why we care about API gateways, what leaps to mind for me is over the last 10 years, people like myself and so many others have helped people move to this new world of microservices, and then they have to confront the hopefully not too shocking reality that this is complex, right? There's more complexity involved. You don't move to microservices because you want to simplify things, right? You move to microservices because you want more reliable, more repeatable, more consistent, more efficient builds and delivery, right? You want to improve your software delivery pipeline. So microservices are awesome in that they give you the ability to decompose your large organizations into small teams. Those small teams focus on small code bases. The smaller the team working on the small code base, the less the cost of integration and synchronization for that code, right? So rather than everybody in the organization having to commit everything into one large repository and integrate it and stabilize it and then deploy it, instead, you parallelize the work so that people work on a particular feature. They break apart into smaller code bases. That code base, any one particular code base, should ideally, knock on wood, be deployable absent the participation of the rest of the organization. So you get autonomy, right? You get the ability to move independent of other parts of the organization. And because you've got that, you can deliver it at whatever speed is most appropriate for you. And because you've got that, you can learn at whatever speed is most appropriate for you, right? So you can see something delivered into production, validate whether what you've done works or not, and then change and respond to that change as you need to, as quickly as you need to, right? So this is a larger discussion. It's all about, you know, the reverse Conway maneuver, right? We're changing our organization to improve our code, and that's born from the insight that Mel Conway had in the 1970s that said that software is a mirror image of the communication patterns of the organization that builds it. So put another way, if your organization is dysfunctional, your software will reflect that dysfunction. And if you want to fix that dysfunction, you can fix your organization, right? And so microservices are all about that. They're not about making things simpler. They're actually, you know, they're more moving parts by definition. It's going to be more complex. So the question then is, how can we have our cake and eat it too? How can we pay down some of that implied complexity, right? That technical debt that arises, that falls out of that move, while also getting the benefits of that autonomy. And I think I think there's, as with all things, there's a kind of a pendulum swing, right? You see that we move software into production, and we're all independent, we're all parallel, and that's one end of the spectrum. And then on the other end of the spectrum is you've got everybody committing to one giant monolithic monorepo code base thing where everybody has to stabilize and integrate, you know, at the same time. And that's the other end. And I think with microservices today, 2021, early 2021, the state of the art is, yeah, we want microservices, we want, you know, autonomy, we want that independent release cycle, we want that independent deployability. And by the way, that independent deployability thing that's a very it's such a small part of microservices, right? I mean, it's such a huge part of why we're doing it, but one thing that falls out of that is unless you know a better way, right? Things need to be deployable independently. That is to say, I shouldn't have to link everything into the same application to get this to work, right? I should be able to deploy something over here and not have to change anything over there, right? And so the implication then is these modules, these things that would have otherwise communicated in the same virtual machine, in the same JVM, in the same process, are now separated over the wire, and they have a network boundary. So how do they communicate? And that's where you get into the idea that you have a service as opposed to just a module, right? It's a network service. So I think, but anyway, the pendulum swing now is we agree that independence is good. We agree that autonomy is good, but are there some things where it really would be better done in a centralized way, in a centralized fashion, right? And if these things exist, can we do them in such a way that they are minimally invasive, that they don't drag us back to the paradigm that we're trying to avoid of having to get everybody to buy in on one particular set of things before anybody can move forward in lockstep, right? And so I think the API gateway is kind of a natural fit there. The API gateway is a way to ensure a consistent level of quality and service for your applications, for your microservices, in a single place, in a central place, right? So you have a bird's eye view of the whole system there. But in order for this to work, the things that you do at the API gateway should be minimally invasive, right? They should have low sort of friction. They should be soft touch kinds of things, right? So again, it's pretty easy to add redirects without changing the underlying or downstream service. It's pretty easy to add authentication headers, right? Because your application ideally doesn't care where it gets the authorization header; it just needs to have it, right? So you can address that at the API gateway. So this kind of stuff is a very natural. These kinds of things are a very natural use for an API gateway. And so I want to talk about that. I want to talk about what we think on the Tanzu team is a very good fit for an API gateway, namely something called Spring Cloud Gateway. Now, Spring Cloud Gateway is a open source project. It is a Java and Spring-based application framework, and it's built on reactive APIs. And in previous installments of Tanzu TV and Twitch and so on, I've talked about reactive programming and so on. And I think I'm sure, in fact, I've talked a little bit about Spring Cloud Gateway, but I wanted to really talk about it today. So I've got code here that you can follow along with at your own leisure. It's here, Spring tips, right? So let me see, take that. Good. It's here. It's github.com spring-tips/gateway redux, and just a lot of stuff here. I used a lot of this in that last video I did, and so we won't be able to get to all of it. But I wanted to talk about some of the basics. So I guess, you know, let's just start from, let's see here, basics. Let's talk about the basics, and then we'll look at some of the more interesting features here. And in order to see Spring Cloud Gateway in action, to appreciate it, yeah, there we go. I guess I can just use that. Okay, so this is a typical Spring Boot application, you know, Spring Boot application annotation, and you've got one. And in fact, this is an absolute minimal Spring Boot application with nothing in it, right? The only thing that's interesting here in this most basic example is I've created a route locator. This is the bean that Spring Cloud Gateway is expecting. Route locators are just an interface with one very simple method. They want a collection of routes. They want a stream of routes, or publisher of routes, or a flux of routes, right? So this is a reactive type. Basically, think of it as like a completable future or a promise or whatever, but instead of just one value, it has multiple values that could be delivered over time, right? So you get a callback for each one of those successive values. And that's it. These routes themselves are just structs, basically. They're not all that tied into the framework. I mean, there's obviously some objects that are from the framework here, but you could easily create these yourself, right? You could create implementations of these types yourself, right? This is just a very simple interface. Given a request and a filter chain, return, you know, do something with it, and then return void. That's, anybody can do that, right? Likewise, a server, you know, given a, you know, you want to have a predicate, an async predicate. So an async predicate, the only method you would have to implement were you to implement this interface is, I don't even know, is there one here? Probably. Let's see. What is the, I guess we could just try it. Let's just see what happens. So async, you know, class my predicate implements async predicate, whatever, string. There, apply. You're going to have to implement apply. So again, trivial contract, trivial thing to do. So the route locator, you could build this yourself. You could actually provide an implementation of this interface with that method, and Spring Cloud Gateway would work with that. So keep that in the back of your mind, because that's useful for later. But for now, we can just use the DSL. There's a nice little builder object that you can inject into your code here, and you can just build up the DSL. So you can say, I want to build routes. So you use the builder method there, fluid DSL routes, and you then build up one or more routes. And I have two routes here. The first route, all routes actually, let me try that again. All routes have three main components, right? You have the predicate that matches the incoming request. Then you have the filters that match the things that act on the incoming request, and then you have the URI, which is the destination for the request. So given a request coming into this virtual machine where my Spring Cloud Gateway code is running on port 9292, given that, Spring Cloud Gateway will match incoming requests that have a path of type of /hello, and I can have other things here. I can say, okay, and the host has to be .tanzu, you know, .tv or whatever. I don't know if that's a URL or not, but whatever. And I could have, you know, maybe there's maybe I have to have a zoned. It has to be after a certain time, and you know, whatever. I can have as many arbitrary predicates there as I want. In fact, I could write my own async predicate as well, right? So pretty trivial. If I wanted to, I can actually say, okay, if Mercury is in retrograde, or if the stock market's above a certain threshold, or whatever. I mean, any arbitrary thing you could say, given that these things are true, then match that request. And if that gets matched, and if there are any filters, and this is optional, right? Then those filters will be engaged. And if there are no filters, then the request will be sent or to be forwarded, basically, to this downstream URI, but otherwise unadulterated, right? It won't be changed in any way. It'll just be taken and then handed over to that URI. It's only if you change, if you have filters, do we change the request for you. And here, the real power, I think, to my mind at least, in Spring Cloud Gateway, are these filters. And so here I'm taking the request, which, as I say, the request that we matched up here has to have a path of /hello. Well, that doesn't work for Spring.io, because there is no Spring.io /hello, although maybe there should be. So we need to change this path, and we can use a filter to do so, to say that the path is now guides. Yeah. So that's one option. There's a lot of other filters here, like retry, right? Retry is really useful. There's a rate limiter, right? There's a There's a, add, let me clean some stuff up here. We can add response headers. We can do a circuit breaker. We talked about that. We can do a redirect. We can remove headers. We can set headers. We can set the output, the status code, the HTTP status. We can do, all sorts of things, right? And again, if you don't find what you're looking for, then you can just write a filter, right? It's very easy to plug in your own gateway filter there and act on the request as you like, right? So you can see, again, these two types are in that route object that we saw earlier, and they're also present here. So you're gonna see them a lot, and that's it. That is the core skeleton of a given route in an API gateway. So I talked ever so briefly about the sort of abstract use cases for an API gateway and why we care about it, but then you see it in code and you realize, oh, okay, that's not so scary, right? Like that's it's just an object that has certain definitions. Or rules for incoming requests, right? It processes incoming requests in some way and then acts on them and so on. So here is another slightly more involved example, which might be familiar to anybody who's ever used a mod rewrite or Nginx or something like that, right? Here I've got a route where I'm taking the incoming request at /Twitter /* wildcard, and I'm taking that request and I'm rewriting the path. So I'm saying, okay, since I know the path is equal to Twitter / * wildcard, I want to rewrite it. I'm going to extract out through a regular expression the wildcard part of the path, and I'm going to replace it so that the outgoing request goes to / wildcard, the variable, right, the extracted part. So what the localhost, whatever my port was, localhost whatever, Twitter / Starbucksman, for example, would be sent to twitter.com Starbucksman. See what I'm saying? It's a trivial example, but this is, I think, something that if you've ever done any kind of Nginx or mod rewrite or any kind of Apache admin kind of stuff, this is life, right? This is basically it. So the fact that we can start or we can proceed from those very simple, very, very trivial, very relatable foundations, and then move to higher level things like circuit breakers and rate limiting and security and token relays and all that kind of stuff is, I think, the power. And the fact that it's the same abstraction for all of that, it's just predicates, filters, and URIs. That's really, really where I think Spring Cloud Gateway is so amazing. It's on these extensional, it's on the possibilities for these extensions. So now that we've kind of have the lay of the land, let's drill down into some of these components individually. Well, let's go back to this first of all. So this route locator is a bean. Like I say, it's just an object that produces routes. These routes that you build, we use the Java DSL, so certainly that's one way to do it. But what's to say that you couldn't source those routes from some sort of definition in the database? That you've got, right? Some sort of database that you've got where you've got a custom way of describing this or something like that. Well, you could, right? You could create a bean of type route locator that talks to MongoDB or whatever you like, right? That's one option. And you could also store that configuration. You could also define that definition using a YAML-like approach, right? A configuration file approach. And that's one of the really interesting things about Spring Cloud Gateway is that while we started it and it comes from the Spring ecosystem, which is developer-centric, right? It's a developer-centric ecosystem. You can treat it like a turnkey piece of infrastructure, right? You can actually write YAML if you like, or property files. Now, I'm not a big fan of YAML. It would be an understatement. It would be the understatement, but might be okay. Might be a thing you want to do here. So let's talk about that. Let's see here. Where's my? Let's see, this one, no. Nope, where did I put it? I put it, basics. Did I do it in here? Nope, where did I put it? Well, I wonder if I subconsciously my brain knew I wouldn't abide YAML, and so it didn't even check it in. I just wouldn't let my brain check it in the definitions. Oh well, that's not a big deal, but we do need to to do it again. So you can define these definitions, these YAML definitions, these config file definitions in a properties file or in YAML. And so the syntax for that, I'm just going to Google that because I rarely use it because I'm happy with my Java code, but I can appreciate that others might not be. Spring Cloud Gateway YAML configuration. There you go. So, is this an older one? No, that's it. Okay, so configuration, blah, blah, blah. There you go. Thank you, documentation. So configuration here, application.yaml. And you know what this means? I'm gonna have to go back and rewatch my own video and just copy, and I'm gonna have to type out the thing I typed out and then check it into this so that people can find it. How awkward for me. Okay, so anyway, here's the basic arrangement, right? You have Spring Cloud Gateway routes, and then just that. You have a sequence of routes, right? So ID, ID. And the ID is just so you can have something you can use to logically refer to it. Here's the downstream URI. Here's the filter, right? And it's assumed that all requests are going to, and these, it's assumed that all requests will arrive at this host import. So pretty trivial, right? You've got a number of different ways you can configure these objects to configure the route locator. There's also a Kotlin DSL, right? So if I go here, I go to start.spring.io, gateway, and this I didn't cover in the video because, you know, just it was already an hour and 40 minutes long, but hit generate, CD downloads, I don't know, okay, generate that. All right, let's see what we get. Gateway. Okay, so here we're using the programming language called Kotlin. It's downloading the internet. Give it a second here. So I'm just going to create a Spring Bean gateway equals, and here I could use RLB route locator builder, RLB.routes, and there's a DSL, right? So that DSL is very convenient because now, rather than having to use the slightly longer form Java API, I can just say I want to create a route, and then the route has, I can say I want to match the path is equal to hello, and the host is equal to .spring.io, and I want to send it to HTTP spring.io /. And of course, I want to have some filters, so I can configure that out. So I set path guides, right? So given a request coming into this host import that has this predicate, apply one or more of these filters, and then send it to this URL, right? So let's see if that works. Let's go ahead and run it. Okay, so it's up and running. Local host, and this is on what port? 8080, of course. 8080 / hello. So curl host test.spring.io, and we're going to say hello. Oops. -v. Okay, what did I do wrong? Host test.spring.io, localhost 8080. Hello, asterisk spring.io / hello. Is that not a thing? Do I need to do that? 400 bad requests. Let's just try that first. Path and host equals. I'm missing something obvious here. Spring.io, hello. Is it just something as simple as this? I'm not even seeing it involved. Come on. $400 bad requests. I feel like I've done my part here. What's the issue here? So path is hello. Host is equal to star.spring.io. Assume content length. Host is equal to start.spring.io. Hello. Wait, hold on a second. Do I have anything running? I feel like I'm talking to the wrong service. Yeah, I have no idea what I'm doing wrong there, friends. That's awkward. Let me see. RLB routes, route path, and okay, let's just keep it. I'm doing something wrong here. And this is why I love APIs, because you can debug more readily. If I haven't put a breakpoint in there yet, but I could is my point. Let's see, curl localhost. I'm not even persuaded that it's actually getting invoked. Let's just try. Okay, when you're not sure, check the obvious stuff first. Okay, so that website definitely exists. Filter, set path, hello, routes, RLB. My gateway. Route locator. Should be the same, but let's just make sure. I just want to have proof that this is actually being run. Oh, thank you. I knew I was doing something so obvious. Okay, way to go, chat. Right on. Oh, okay. Did I do that wrong? Capital H, is it? Thank you. Okay, so my code clearly worked. Oh, I'm using a brand new JDK that doesn't quite work all the time. So you're going to see issues related to Netty, right? And the native APIs. Where's that Netty? Yeah, macOS DNS Resolver, Netty. This is native code somewhere in the bowels of my JVM that are eventually causing issues for Netty. That's not, it still worked. Obviously it worked, right? So I don't know what the bug is. It'd be nice if they just put it back in the debug log, but they didn't. But you can feel free to ignore that. I'll, when I make bugs, I'll be very forthright and say, hey, I screwed up because I do a lot. Okay, so good. So there's my little route. Thanks to the chat for rescuing me there. So that worked, right? That's the Kotlin DSL, very, very simple. And yet, but it's just another example that doesn't matter how you get this object, as long as you have that object. That's the API. And you can have multiple objects like this as well in your application. So we've got our gateway code here, right? This is a trivial example. We've got the YAML file, we've got the Java DSL. There's just a lot of different ways to factory that stuff. And of course, if none of those suffice, just feel free to implement the route locator interface. It's not that scary, right? So now we have we can see that there's a lot of different ways to source your configuration. Let's talk about some of the things you can do with it. And where I think it really helps is, well, there's two things we're going to look at. We're going to look at routing, and we're going to look at reliability, right? So thus far, I've talked to you about just a basic route, a basic like predicate that matches the current host and port, and then it sends it on to a hard-coded URI. But as often as not, you might want to send that on to a service in your service registry. And so Spring Cloud has this concept of a discovery client. The discovery client is a abstraction that lets you talk to different service registries. The interface is patterned off of the Eureka one, and it's now just, we have interfaces, we have implementations of this interface that have, you have three methods, right? You have to get a description, get the instances for all the service instances given a service ID, a logical service name. So you might have the same order service on host 1, host 2, host 3, host 4, and given the string order hyphen service, it would return the descriptions of where those things live, the host, the port, whether it's secure, any metadata about it, the scheme that's used, etc. And then, so that interface is really useful because we have implementations for Cloud Foundry, for Kubernetes, for HashiCorp Console, for Apache Zookeeper, for Netflix's Eureka, etc. So what I'm going to do is I'm going to use Netflix Eureka, and I'm going to spin up some other microservices for our reference. So I've got that code here. The first thing I'm going to do is I'm going to spin up Eureka, and normally I would just write this code live, and it wouldn't take all that much longer, but I want to get it all done within an hour, and we're going to cover a lot of stuff. So here's a brand new Spring Cloud Netflix Eureka server. And again, you're more than likely going to just use a container or at the very worst, download a tarball and spin that up. But the fact is, with Spring Cloud, for Netflix Eureka in particular, and only for Netflix Eureka, it is trivial to just create a brand new server. That's the entire code footprint for Eureka. So I'm going to hit run. And in order for that to work, I needed to tell Eureka on what port to run. It's arbitrary, but it's a pretty common thing for people to run on port 8761. And I'm also telling Eureka, which is at the end of the day also a Spring Boot app, I'm telling Eureka not to, as a Spring Boot app, register itself with itself, right? Because it's going to have the code on the class path that wants to reach out to whatever Discovery Client implementation is on the class path and register itself. But it is itself the registry, so there's no point in registering itself, right? So we're just disabling those bits there. Okay, so if we go to localhost 8761, we've got ourselves a Eureka console, right? It's naked. There's no data in there. There's no apps, no nothing, right? But you can see pretty trivial. And this is what Netflix uses, right? This is the same service registry that they use. And by the by, they created this after they moved to AWS, where they have the ELB and things like that, right? So this isn't just about a better DNS. There's a bunch of use cases that are supported that you just don't get with regular infrastructure. So one of those being something like service hedging, right? Where you want to find, when you want to talk to different downstream services and different instances of the same downstream service, and then pick the response that returns the fastest and preserve that one and discard the other ones, right? In order to do that, you need to ask the system, the topology for distinct instances of a given service, right? So here I can programmatically go to the service registry and say, hey, give me distinct hosts and ports. I want the same service, same logical service on distinct hosts and ports. So now I've got my registry. Let's spin up a service, and for our purposes, I've got some throwaway services just for reference for our example here. So I've got the order service. Let's run this one. And I won't go into the code all that much, but all you need to know is it's got the Discovery Client implementation on the class path, and it's going to run on port 8181. And it's got a name there of, logically enough, orders. So if I go here, you can see now that service has spun up. It's now in the registry. It's available. Okay, so what about the other service, Josh? Let's see. We've got the registry. We've got orders. I think I had customers. Yeah, that's the one. So customer application. Good. Just a bunch of random, and again, these are trivial examples that don't even have databases. I wanted to make it so that you could just git clone and run it, right? So there's not even, I didn't even bother with an embedded database. There's no well, maybe I did for this one, but there's no pretense of this being like a real thing. It's just dummy data so that we have something we can send requests to, right? So I'll go back here, and you can see the services now, both services are discoverable. And were I to start up multiple instances of the customer service, you would see this would go up to 1, 2, 3, 4, and you'd see the distinct host and ports. By default, by the way, that is going to, let's try it out. Let's see I think that's not going to work out of the box if you're running it on the same machine. So if you're running it on different containers, it'll work perfectly. But if you try and scale up to multiple instances on the same machine, you might have issues. Let's just try it. it's easy to fix, or at least it's trivial. Let me see. So there's the other problem is that we might be running on the same host and port. Yeah. So go back to customers, properties. I'm going to make the port arbitrary. So it'll just pick any arbitrary unused port, and it'll spin up on that one. So I'm going to restart the customer service there and spin up another one here and another one there. All right. Okay, so you can see I've only got one of them. And the reason I've only got one of them is because it creates a key, right? The name of the service and so it's the IP and the name of the service, but not the port, right? Or the port is 0 in this case. And so it doesn't do a great job of distinguishing itself. So just keep that in mind. I think you can, what is it? Eureka ID, something like that. Instance ID maybe. And I think we can do random int. Let's just see what it gives us. Okay. There you go. So I'm giving it random numbers now, and it's distinguishing them. So that's how you would solve that problem. Obviously, you could plug in something more useful here. You can use, the Spring application name, random int, right? Or whatever you want, right? So something like that, in which case that would actually have customers, hyphen, and then some random number. And now they're distinct. And this is only a problem you're going to have when you don't have distinct host and ports, right? If you have two different ports, then you won't have to do this craziness. But if you're trying this in your local machine and you're having that issue, now you know. Okay, so I'm going to go back to the happy world where I have just one application because I was happier there. And this will just be 9191. Good. Restart this. Okay, so there's my application. It's started up, it's registered in the service registry. I've got the two services. I want my gateway to talk to them. So now we go back to our code here and we can go to gateway discovery. And again, this is just a Spring Boot application where I've got the Spring Cloud Starter gateway code there, and I've got the discovery client for Eureka, right? There's a Spring Cloud Starter something dash client, right? So it might be Zookeeper dash client, it might be console, etc., right? Okay, so the code here, you can see the first thing you get when you use a service registry with Spring Cloud Gateway is that now you can avoid magic hard-coded DNS entries in your code, right? So the URI is now a load balance. The scheme is LB, which stands for load balance, and it's customers. So we're telling Spring Cloud Gateway, whenever a request comes in that matches this arbitrary predicate or whatever, goes to these filters, whatever, then we want to send it to an instance, any instance of the service that you can be discovered by talking to the configured service registry, in this case, customers. And of course, in this case, we've only got one instance, so it's going to go to that one. But were you to want to try sending it to one of the multiple, you would have to do what I just talked about. Okay, so localhost, there's the IP, there's the service, etc. The other thing that's nice about that is, the other thing you start to appreciate with Spring Cloud Gateway is that we have this event you can listen for in Spring called the refresh routes result event, right? And this event gets emitted for all sorts of reasons. If you add a service to the service registry, you'll get an event. And when the application starts up, you'll get this event, right? So anytime the registry takes stock of the available destinations of the available routes, you'll care about that. And the reason it would automatically care about, the reason that Spring Cloud Gateway would automatically create new routes based on the presence of a service registry is because we have this configured property here where we're saying Spring Cloud Gateway discovery locator enabled equals true. So in this case, when Spring Cloud Gateway starts up, it's going to automatically connect to the service registry, the discovery client. It's going to ask it for all the available routes that are in the registry, and it'll automatically create routes for us based on those logical names. So maybe that's all you need, right? Actually, if you look at what I've done here in the gateway application, even if you commented this out, you might have something interesting already, right? Because what this is going to do is it's going to spin up, it's going to see customers, and it's going to see orders, and it's going to create a route called /customers / and /orders / right? So we can restart this application. And I haven't even enabled this one, right? It's not even there right now. It's just, we're just doing the defaults like what you get for free. First things first, you can see it's aware of these 2 routes, which we didn't configure as far as I know, right? So it's aware of a route called customers * basically, and orders *. And that route will eventually be rewritten as a thing that gets sent to the downstream thing and doing that basic regex thing that I showed you earlier, right? So let's see, if we go to host and port, what host and port was this? 9292, localhost. And so I'm going to go to customers. Is there no endpoint called customers? Oh, this endpoint is a server-send event stream in the customer service. So if I go here, that service is designed to be intentionally slow. So here, customers flux, which is a reactive stream. That reactive stream I'm producing up here, and you can see I've got an intentional delay by 3 seconds. So every element in the service and event stream will be delayed by 3 seconds. So you can see it's just trickling through these names. Every 3 seconds we'll get a new result. So there you go. That's useful, right? You've got that ability to just send any arbitrary request downstream, orders 3, whatever, and there you go. That's much faster. So I'm sending this to the order service with a path orders /3. So discovery client integration, pretty useful. You get a lot of useful things out of the box. You get the ability to automatically set up routes. And again, imagine you have a Spring Cloud Gateway app. It has no code in it except for those 3 properties in the property file. And you can then deploy, that can be your backend as a front end, right? You can add security maybe. You can deploy that and then have your iPhone app or your Android app or whatever talk to that one gateway. And there you can introduce things like security. So now, even though you've got these different backend services, and who's to say what languages they're written in, obviously, as far as I'm concerned, they should be in Java or the JVM and Spring, and that is the right way, TM. But it's theoretically possible that there's some other language out there that you might want to use. So it doesn't matter, is my point. Because this gateway sits in between that service and the outside world, we can get a consistent sort of view of that data from the gateway. So gateway, I love it. Let's see here. I've got this. I didn't even bother with this route. We don't need it. So that's one thing that's useful. Now that you've got configuration, and now that you've got routing kind of squared away, we can then look to some of the more advanced things that you can do with that gateway. And one of the things that I think really, one of the things that a gateway can do is ensure a consistent level of service for consumers of your application. So let's look at a number of different use cases here. Let's say I've got an endpoint that's expensive, right? So given a request coming into this host and port that I want to send to the downstream service, but I want to do so sparingly, right? So what I'm going to do is I'm going to say when somebody goes to this gateway code /expensive, I want to take the request and I want to apply. Oh, I got ahead of myself. Let me go down here to the simple one first. Let's say I go to the gateway code /error, whatever, wildcard. I want to send that to an instance of the customer service, right? So I'm going to take the path that was sent to the gateway code and send it to the customer service. But if there are any errors, I'm going to retry, right? It'll retry as many as 5 different times before giving up. And this customer service, I've purposely written a code base, some code that'll fail when, it'll fail predictably for the first 4 times, right? So here we go, error ID. So basically, the gateway is going to send a request to /error /ID, and there I'm going to keep a count. I'm updating an atomic number here, to a thread safe concurrent, number here, atomic number that'll keep count of the requests that have entered the gateway and then been forwarded to this downstream service for a given ID. So this is kind of like a bespoke session, just so we can see over successive runs how many requests have been served for a particular ID, distinctly, right? So the error count will get updated on every single invocation. If the count is less than 5, then we return a service unavailable. Well, that's going to trigger the retry. So we'll see this will log out returning an error for request number, blah, blah, blah. And we'll see on what count we are. So for given this key, here's the value. It's a map, basically, that I'm creating here, a map of keys and IDs, keys and counts for that ID. And then on the 5th try, we return a proper response, which is down here, right? It's fine. So we got the customer service. Let's run this gateway code here. Stop that. Run this one. Alrighty. So now 9292, the what port? Yeah, 9292. We're going to send it to /error/ you know, whatever. Paul. Oh, I have security. Why do I have security? I have security because of the rate limiter. And what did I used a hard code using password, so that should be easy enough. JLong PW. Okay, good. So curl -u JLong PW HTTP localhost 9292 /error whatever Tiffany access denied. Did I JLong PW, and the request goes to you know what the issue is? I want to lock down everything, so get rid of that. Come on. I can tear out Spring Security if I need to, but I'm going to have to add it back in a minute. So good. There you go. So you can see it took a split second. Did you see that delay, that hesitation? And that's because behind the scenes, the gateway had to retry the request. And so if you go to the downstream service, it made the request one time, got an error, made it the second time, third and fourth time, all errors. 5th time, eventually it gave us the right response. And you can see that logged out here. So each time the downstream service returns a status code that we don't like, it gets retried up to a certain threshold. And that retry is really, really configurable, right? I haven't even begun to configure. So this retry, you know, there's config here, and you can say retry config dot set exceptions that you care about. You can set the back off time, like the first back off should be like 1 second, and then maybe the maximum back off should be like 10 seconds, and you can have like a shakiness factor, and you can set the number of retries, and you know, set status codes that you want to listen to. Like here, I'm listening to the default. What I just showed you is listening to, it's listening for any errors of the 500 series. So service unavailable is 500 something, right? So it's gonna look for that status code. But you could say, hey, I want 404 also, any 404 and also 500, right? Any 500 series status codes, for example. That should all be handled here. Or if it manifests in an exception in the route itself, in the Java code, then I also want to have that retry logic kick in. So yeah, really flexible. I just did 5, you know, just the number of retries, but there's a lot more to it there. Now, suppose you wanted to also have a useful default. You wanted to back off and should something fail, you want to give a default response, right? And this is part and parcel of building microservices. You want graceful degradation. You want to know that when you build something, it's going to degrade gracefully. High-performing organizations do this kind of thing all the time. They'll have like a search engine service, and they'll say, "Oh, Tiffany's causing errors. PHP. I should have done it. You're right, Paul." In the chat is suggesting I should have done error /PHP, and that's true. That's true. I'm sorry. I take back the example, and I'm going to use PHP henceforth. But suppose you wanted to have not just a retry, but also a default value. And so here's another thing you can do. Instead of using just a retry, which you know might be enough, you can also do a circuit breaker. And a circuit breaker, basically it's a retry with a fallback. So the fallback here is I'm saying when a request goes to /customers, then we're going to forward it. We're going to forward it to load balanced customer's endpoint, the customer service. But if anything should go wrong, and for example, if the service is not available, then we're going to have a fallback, right, URI, and that URI has to be another route in Spring Cloud Gateway. In this case, the name of the route is default, and I've configured that route right here, right above it, right? So, and so when Spring Cloud Gateway can't reach this route, when it can't succeed on that route, it's going to then execute this route based on this path for such default, and there, you know, I can do whatever I want. I can send it to another website. I can provide a default response. I can provide a custom filter. You can log it. You can, you know, whatever you want, right? You can do whatever you need to here. Here, I'm saying, okay, if I can't get the customer's data, and again, this is just for a demo, instead, I'm getting the guides, right? So these are very distinct responses. You wouldn't, you know, it's just so that we can see it working in action. So let's go ahead and try it out. So that's on localhost 9191, and we're going to / customers. Right now, the customer service is up and running. So customers. So there's the data. Yeah, it's fine. We're producing it's still running, right? It's the same reactive stream as before. But now what I want to do is instead, I want to shut down the customer service. That's this thing right here. Goodbye. Okay. If you go to the service registry here, you can see we've got the gateway, we've got orders, but no more customer service. So now if I retry the gateway code, eventually it'll just give up and go to the guides output, right? So very, very convenient. You can have default values there. Okay, well, now what about this? Well, this is, you know, going a step further, maybe going a step in a different direction now. Maybe I want to limit the downstream service. I want to limit the load on the downstream service. So for whatever reason, I might have some endpoint that is expensive and I can't afford to have just unbounded traffic to that. And really, you know, where can you afford to have unbounded traffic, right? And you might be able to have, there's two different kinds of bounds here, typically, that people deal with. One bound is the aggregate in total, the whole world. Right? It doesn't matter, you know, who they are, what they're coming from, what they're doing. They're all part of the same quota that has to be met, you know, to be allowed to make a request at a given time. So that aggregate number is only useful if you have something in the rare case where you have an absolute upper bound in some downstream service. So maybe you've got an SLA with a vendor, and that vendor will only do so many requests per second. It doesn't matter who initiates the request. It can only be so many. Or maybe you've got a mainframe, which are notoriously hard to scale up, right? Go to IBM and ask for another mainframe on demand and see how much they laugh, right? It won't be good. So you need to plan that. You can't just put another one into rotation. So it's not like Kubernetes or something like that, where you can just spin up a new deployment or a new pod in a deployment. And so in that case, it might be very useful to say, okay, look, we can't handle more traffic than X, and whatever X is, I need to upper bound it. And so you can solve that problem pretty easily by providing a rate limiter, right? The rate limiter has two components. It has the actual thing that keeps track of the number of requests destined for, or intended for a particular URL, and then it has the count of those requests, and that count lives in this implementation, as I've configured it here, in a Redis database, right? So I have a upper bound of 10 requests per second, right? And so in order to figure out which key in which to store that atomic count, that absolute number, I need to provide a key resolver. That's this thing right here, PKS. And the key resolver, in this case, where's my key resolver? The key resolver could be just as simple as, it could be as simple as return new key resolver, and it returns a string, or a string wrapped in like a promise, basically, or a reactive stream. So mono.just Maria la chiave, right? So that's one key for the whole world to share, right? It doesn't matter, there's no distinction on the nature of the request. It's just everybody has one count in Redis. So basically, in this scenario, I guess what I'm trying to tell you is that you would have to spin up a Redis database that has one key which stores one number. So hopefully you can repurpose that Redis database for something else, because this is not exactly a heavy lift. But the benefit of having that service registry, the benefit of having Redis is that now I can have 10 instances of the gateway code, right, the gateway itself is load balanced, and it doesn't matter to which node a particular request is directed because it'll debit from the count. It'll increment the count in Redis, and so they'll all have the same view, right? If I say there's only 10 requests per second, then Redis will keep the track of how many requests you've got, and all 10 nodes will see that budget. They won't duplicate or triplicate. They won't multiply the number of requests for every node added, for every instance of the gateway added. So that gateway code, really convenient, right? That's one way to do it, is to have an absolute key. The other is to say, okay, I don't actually have one of those obscenely like rare things that you just mentioned, where you have like a mainframe or something where you have an absolute upper bound. Instead, I am running on Kubernetes, or I am running on Cloud Foundry, or I am running on whatever brand X is. I don't know what Mesos, Docker Swarm, whatever, right? I'm running on something where it's self-service and trivial to spin up a new node, in which case your problem isn't absolute upper bound. It's more about just wanting to ensure that people are playing a good game, that they're not taking advantage of the system, that they're not depriving others of resources unfairly. And so in this case, it might be useful to instead say, oh, okay, well, I'm going to limit it to X number of requests per user in this case, right? So you can create a key resolver that looks at the current request, and it extracts out the current authenticated user, the principal. And if the principal is there, then we use the principal's name as the key. So if my username is JLong, then the key in Redis would be JLong, and the count would be associated with that key. But every other user would have their own key, right? So, and if there is no key, then of course that person isn't authenticated, and therefore we don't let the request go through, or at least that's the default behavior. So you can configure that key resolver to use the principal name key resolver, as I've done here, but it's also the default. So if you don't even have that, it's the same as doing what I just did, right? If you comment this out, like I just did there, it'll still work exactly the same. It'll still look for the current principal in the request. And that's why, friends, I have Spring Security enabled in this. So let's run this code now. Gateway, well, first of all, is customer service back online? Start that. And then gateway is running. So let's see, it's going to go to expensive. And that's why I have Spring Security, so I can have a key, right? I need a key in the database. Okay, expensive service unavailable, message, blah, blah, blah. What did I do wrong here? 9191. Same problem. 44 not found. What am I doing? This is port. Oh, sorry, this is the port. What's service port? There you go, hello world. Okay, that's fine. So now what I've done there is in the downstream code, in the customer service, I have an endpoint. Where did I put it? Error. What endpoint did we say we're using? Hello, it's hello. So it's going to this endpoint here. And here again, I'm just keeping a count, and I'm basically doing what the rate limiter is doing. I'm keeping track of how many requests we've got per second, right? And I'm keeping a count of that and just logging it out so we can kind of see what's happening. So when the request arrives in hello, I get the current time in milliseconds since the epoch. I divide it by 1,000 to get the seconds, and then I increment I add the current second into a map, and then I increment the count of requests that have all got the same second, the same key, and then I print it out. So we have a rough idea of how many requests we've got per second. So you couldn't see this down here. So there's been one attempt for the given second, which is that second there. There's been one request there. So that's now, some load here, sort of. Okay, whoa. 404 not found. What did I just do wrong? That one. That's the one that worked, right? Yeah, that's the one. So while true, do done. There you go. So I'm making requests, but as I go to the downstream service, you can see it's never ever exceeding 10 requests per second. It'll give you a 429 eventually. Let's see if we can catch it doing that. I see 429. There you go. HTTP 429, and then the rate limiter also gives you the number of headers, the number of the quota that you've got left, right? How many requests you can make, how many bytes at the apple you can have in that second, right? And if you've exceeded that, if this is 0, then you get a 429 header, but otherwise you'll get the response. So you can see I've got a bunch of 429s in there, and then some got through invariably. Some, the first 10 got through. So that, my friends, is a quick look at Spring Cloud Gateway. What else could we have covered in here? There's some more advanced features like the token relay, where you can actually do federated authentication, authorization, and things like that. And really, I mean, the sky is the limit. That's the point. And we don't have a lot of strong opinions beyond that you should use an API gateway. About how you use an API gateway. And in Java, of course, we can have strong opinions. We can have opinions at all as developers of Spring, but we don't get to really have a strong opinion about production, right? And so obviously, production is different for everybody. But if you're using Cloud Foundry, which is an open source cloud platform, or if you're using Kubernetes, which is an open source way to write YAML, then we can have an opinion about that, but that's a separate discussion. And so to support that, to have a sort of operationalized, scaled out, secured thing, we built a product that you can, it's not open source, you buy it, right? It's something that we, like I said, we just released the Spring Cloud Gateway for Kubernetes product last week, I think it was. And that's actually all of what you've seen right here, but now all the things that have to do with getting it deployed into production, getting it scaled out, getting it so that it automatically responds to changes, and also getting it so that it's not centralized, right? I can have a YAML file in my my application, my microservice, and as long as that application goes into production through a CI environment that then eventually kubectl applies something somewhere, right? It gets it deployed into there. It's a Kubernetes object, right? It's a routing object, so you can actually define, very much like the route definition I showed you earlier in YAML, you can define that route inside of this Kubernetes object. It'll automatically get registered in the cluster. The controller that we've got in Kubernetes will see that new object, and it'll automatically create that route for you in the gateway, right? So the definitions of the route live with each microservice in the microservice itself, in the same pipeline. But there is just one gateway in the cluster, in the Kubernetes cluster. So that's the logical next step to my mind, right? And that's what Spring Cloud Gateway for Kubernetes does. And I just think it's like, I didn't know I wanted that until I saw it, and now I'm really excited about it. So I hope you got something out of what we looked at here today. Obviously, Spring Cloud Gateway, it's open source, so you can, it just works. It's just really, really powerful. People are using it at scale. It's fast. It's, it's fine. I'm just very excited about, given that we've had Spring Cloud Gateway for years now, I didn't know we could ask for more. I didn't know there was more to that story until I saw the productized version. Maybe next time I can do a demo of that that product version. That is so cool. It's just really elegant when you think about it. It's just, you have your Kubernetes definitions with the microservice. So you really can, in that case, have your cake and eat it too. You can get independent deployability, but while also still having control for each microservice. You don't have to file a ticket to get something changed in the route, the centralized router or the centralized gateway. I want to thank you for your time. Hope you got something out of it. I'm going to see if there's any questions. Nope. Looks like there's just the usual silliness. So, oh, what idiot called it Spring Cloud Gateway and not Nurika? Oh, that was Paul. That wasn't a regular person. It was just, that was Paul. All right. Thank you, everybody. If you have any questions, happy to answer them. I'm, as always, your host, Josh Long. I'm at josh@joshlong.com or Starbucksman on Twitter. Okay. So thank you very much for your time. Appreciate it.